Hello, everyone. Thank you for joining us here today to this another session of our DCOMP early career office hours. Today, we focus specifically on research software engineering. I do not want to go very much into the specific of this career path or type of job because we have two speakers that will today, let's say, tell us a lot about it. So let them take care of it. I just before we start would like to highlight some opportunities that the APS provides to students, which are very useful for who's trying to figure out their career path. So we have some specific tools, which are, for instance, physics profile, career navigators of job boards or guides that basically help you connect with other people that are pursuing a career in physics or allow you to, let's say, see what are the opportunity that a curriculum in physics allow you to pursue it. But also like the APS provides mentoring programs, which basically allow you to be connected with some expert in the field that can tell you how to, let's say, optimize your curriculum or your skills to pursue a certain career, or like what can you, let's say, put your physics ability to in where is, let's say, where you can apply your physics capability in, let's say, the career path and the job market, let's say. So also, if you see that like you are interested in this type of career, research software engineering, I would like to highlight that the DCOMP is also organizing a specific session, which is much longer than the one we are having today about this research software engineering. And this is going to be done in the Global Physics Summit in Denver this year. And it is going to be on Wednesday, March 18 at 5 p.m. And it will be in the APS Industry Room 501 at the convention center. So now that the small introduction is done, I would like to introduce Sandra Gesing and Gabriele Bozzola. Sandra is Executive Director for the US Research Software Engineer Association and is also a senior researcher at the San Diego Computing Center. And we also have Gabriele Bozzola, which is currently an applied scientist at the Amazon Center for Quantum Computing. Both are very active member of the research software engineer community. Okay. And now I would like to leave the word to Sandra, which will start telling us a little bit more about this type of career.
Thank you very much, and thank you for having me and the kind invitation and introduction. With this, going to my screen, and you should see it now really in the presentation mode.
Mm-hmm. Yes. Mm-hmm.
Great. Yeah, so as Francesco said, I will talk about research software engineering and you all, and the role you could have and community careers and USRC. And so research software engineering and science is often really driven by hidden contributors. So I compare it to the human computer. So some of you might have seen the Hidden Figures movie. So these human computers were already, employed by Harvard in the 19th and early 20th century, and also 1935 then with NASA. So that was on the movie about that they did all this work, but were never really recognized. And I compare research software engineers still a little bit to them, that it's not so, well known, but that is what we want to change. So, what is a research software engineer? And it's really between a researcher and scientist. Most of you will be physicists, I would assume, being here at the APS DCOMP office hour. And it's really this, an RSE sits between professional software engineer and research scientist and, yeah, traditional research IT support also at some institutions. And I like these two definitions. One is from US RCs on our website, that we really like the inclusive definition of research software engineer. So everyone who really use expertise in programming to advance research. So if you are creating software packages, if you are contributing to software package in physics, that is exactly, you are a research software engineer. And it's really combining professional software engineering expertise with intimate understanding of research. So USRC, the first step started really in winter 2017 to 18. So there was a US survey of RCs, so we got 175 responses, and 12 responded that they would be interested in to build a national community. And then there was the International RC Leaders Meeting in 2018, and with 5 US delegates, and you find me somewhere in the back in the picture. And then we did build the steering committee and had the first steering committee elections and annual general meeting in 2020. So these were the first steps, and the growth. We are really very happy about the growth, and I hope after this you all will also join. Joining is free. So you see, we did grow from about 10 at the beginning, 10 members, to over 3,800 members in December. And our mission has really four topics. One is to create a professional community, to share knowledge, to build connections, to share resources, and advocating that this role is really important, has a lot of impact on research, because most of the research nowadays cannot function without research software. And it's a critical and valuable role to be a research software engineer. And to share resources, like to information, to material, to support individuals, but also groups. And we are really also passionate about diversity, equity, and inclusion, to encourage and improve the diversity within the research software engineer community. And if you look at the beginning, so it started in 2013 in the UK. So, and they also coined the term research software engineer. And it's, as I said, a mixture between scientists, researchers, and software engineers. So if you don't like the engineer part of it, yes, we know that the coin is not optimal, but we also address researchers, scientists with this engineer term. And in 2025, by the way, at the end, and now I think 2026 in January still, these are all the research software engineer associations that were founded in the last 10, 12 years. So there's now a Digital Research Alliance of Canada, for example, that really has this. They cannot call it research software engineers because it's a real profession in Canada, and you have to have the degree in research software engineer to call yourself an engineer. So France has the same, so they have also their research software association, but they cannot call it engineer. But then you see it's really UK, it's the Nordic countries, it's Germany, it's Belgium, it's Switzerland, France, it's in Africa, it's in Australia, New Zealand, in Asia. So it's in Chile. Chile is one of the newest ones. So you really see it's a worldwide movement that acknowledges that research software engineering is so important. So, and we have resources, we have a website, newsletters, a Slack workspace. We are very active on Slack, LinkedIn, Twitter, a job board that is also important. To have, find jobs. We have a YouTube channel. We have monthly community calls, an annual conference. So you see the picture from last year's conference here on the right-hand side. We were almost 300 people. We have a DEI speaker series and media club, education and trainer speaker series, national lab speaker series, and conference panels. You see me, for example, on the left-hand side. We are going to supercomputing as exhibitor. We have informal meetups in 2026. We will be, by the way, in the Berkeley area on the West Coast with the conference. So, but it's also a very active part of the community. Are really working groups around code review or community calls, education and training, mentorship programs. We have an outreach working group, RSE empowerment in national labs, user experience website, and affinity groups, and also regional groups. So that is also something we want really people to connect and in their local area, and maybe also have in-person meetings because a lot is also online. So we have resources like how to hire, manage, and retain data scientists and research software engineers, or how does a research software engineer, how really creating a career path and a career. So that was a collaborative effort with IEEE Computer Society, for example, and also how to build local groups. You can find resources like this on our website. And why really do members join? Because they feel addressed and included. So we ask, and to belong to a community because we are in this middle of between research software and science and research. So that it's a space for discussion and a space for learning and really to support a non-traditional career path. So that is why people join USRC. And if you look at research, software engineering and AI, so AI is an interruptive force at the moment, and it will stay like this. It won't go away. I mean, especially generative AI at the moment. So there's code generation, there's workflow automation. There are also challenges, we know that, reproducibility, the transparency, ethics, and also it has the potential and it will reshape roles. And I'm convinced that research in the next 10 years, AI agents will be integrated in research platforms, that they will propose experiments, help drafting papers, and that human-machine collaboration is more the norm. So it will be really, I think, research will change in the next years. So, and as research software engineer, so there are two modes we can have. We can just survive in this environment. So with being passive or fragmented in the community or sideline, or we can thrive. We can have intentional activities. We can redefine our roles. We can be globally connected. And you have seen already the picture with all the different associations. So there's a chance for global connections. And you might have heard when it comes to software engineering, different corporate narratives. And therefore, I wanted to bring it up here. For example, NVIDIA, the CEO said, AI means everyone can now be a programmer. Or, really the industry's goal is to create systems where nobody has to program. I, I will say more about these. Zuckerberg said, so that AI systems would soon reach mid-level and engineer capability, and that there is a large-scale automation of coding tasks. So the Google CEO is a little bit more careful and also more cautious about the environment. He is more about augmentation rather than substitution. So that there's 25% of new code at Google is already generated by AI, but under human oversight. And I think the overall narrative at the moment is really they often emphasize the substitution of human programmers by AI and that we might be displaced. I don't agree to that. I think what they miss is they overstate substitution. They understate the oversight because human expertise will be further needed for validation, for reproducibility, and also I think the socio-technical roles remain essential. AI cannot fulfill this, and we need the people. So at the moment, even also the CEOs agree that there needs a very experienced programmers to have the oversight. But how do you get really experienced programmers if you don't build the workforce? So I think there is really a little bit oversight, over mentioning of the rhetoric is wrong in this case. So I think we go for thriving, not only surviving, so have really a globally established profession. And we know that AI is reshaping our research software work, but our role is not obsolete, but evolving. It will change. It did change really to interesting tasks also. And we have to do an intentional action for this. But RSE can be community educators and technical integrators because that is exactly what is needed with AI now. We can have a leading role in that case. And so it needs really to come from support staff to recognize career paths and So it's around domain, computing, engineering practices, and AI. We want international coordination and worldwide RSE associations to work together. And that funding gets also the workforce support to get into AI, to get into really software engineering and really recognize RSE contributions in evaluations, like accepting that research software is also a scientific outcome and not only a byproduct. And so part of my work, for example, you see me here in Washington, D.C. So I was there for talking with senators and governors to talk with them about that, how important research software is. With funding bodies, we have this year, it's not next year anymore, it's January. This year we have our first International Research Software Conference in September. So we are working with the Bureau of Labor Statistics to get research software engineer included in job titles. And for example, with OECD, we had a workshop on research software, and there are 28 states. So that was the first workshop ever from OECD. And 28 countries are part of the OECD, who recognize that research software is an important topic for research. So my journey to USRCE, so you hear my accent. I'm from Germany, and I started with an apprenticeship. So I did not do directly a master's. So, and this apprenticeship is similar to a bachelor, and it's half was with the university and half also learning at the university and having, to study. And so I became a research software engineer first in industry. So I was in industry in Germany and decided to do my master's besides work. And I went then I went in Tübingen then for a PhD. And that was still in Germany, but I started to already collaborate with Edinburgh. So I worked for the University of Edinburgh in Scotland. I had a research visit in Budapest in Hungary, and then I came to the US, to the University of Notre Dame, first as a research software engineer, and then I moved to being a research faculty and bring money in for research software engineers. And now I'm the executive director of the US Research Software Engineer Association and one of the co-founders. And these are the different computers, by the way, I work with. So I started with an Atari ST 1040. So probably most of you have seen those only in museums. And then with the 386 PC, I worked on an IBM T-Rex. And nowadays I work on a MacBook, and I had IBM ThinkPads, yes. So, and you can get all involved with USRSE. So most activity is happening in Slack. Can you post in a channel? Yes, you can. Can you create a channel in Slack? Yes, you can. Can you start an initiative or organize an activity or event? Yes, you can. Can you join a working group? Yes, you can. Can you start a working group? Yes, you can. Is USRCE only for HPC national labs or universities? No, it's not. Everyone can join. And these are our unicorns. We have little unicorns as mascots. And if you want to give some money to support USRCE, you can order one and get one of them without the headwear. So, and with that, this is my presentation, and I'm happy to hear questions.
Thank you, Sandra. Is there any question for Sandra? I think we can have 10 minutes of question, then we will move to Gabriele, and then with the remaining time, we will ask other questions as well. So please ask away, you're free to talk, otherwise you can write questions in chat. And in the meanwhile, I'd say I have a question for you. Okay, let's say, for instance, that how does somebody, that effectively comes out of, does a PhD in computational physics in some sort. So like during his time, he learns how to use, let's say, computational tools, and also develops and learns how to code by itself, or like, his experience in coding is like how can such a person, for instance, pivot toward a research, well, not research, a career that is more focused in research software engineering in a sense. It is something that happens by chance, or is something that you can purposely steer yourself toward in a way?
So that is a great question. Yeah. You can steer it yourself. I think really a good connection is to start with the USRC, for example, to building community, or to look at the job board, look at the education and training group. What are, for example, because I know that is often not taught, but what are the best practices in software engineering? What do you want to learn? What makes your life easier for contributing to code? What are code resources where you can contribute? Well, what is maybe open source? Um, we have a student channel, for example, where people can exchange in Slack experiences. We have, I think, a good start is always also to look into a working group like how to test software, how to, you know, peer make a peer review coded software. So there's several ways to learn what good practices are, and um, and there are recommendations for material or for exercises to go through. What we are working on the long run, that there is really research software engineer classes at universities, that there hopefully will be one day a curriculum. So when somebody asked me, what do you think would be success of USRC? I always answer, if somebody at high school is asked what they want to become, it would be fantastic if people say, oh, I want to become a research software engineer. Then we were successful. Because then we have the curricula and the job official description and people adapt it.
No, thanks. And also, like, another question that I have is like, what is like one of the most important skill that one would need to acquire to become, or like to be successful as a research software engineer? Like, if it is, for instance, some specific code language, some specific practices, or I don't know, for instance, like a.
So I don't think that one specific language is the one that is the most important. I think the mindset of being curious, being willing to learn new things, being open to that this is, we are in a research environment. So, and if you come from physics more also, yeah, if you love your research, you know how, it can change, projects change. That is why it's research. And being really open there, being creative, being a problem solver. That brings you will learn as you will learn the details of syntax of programming languages. Is it good to start if you, for example, say, okay, but which programming language should I start at the moment with? I would say Python or Julia. That are the ones which are mostly used at the moment. Besides, of course, I'm in physics, the physics group here. Fortran also won't go away. There's so big codes in Fortran. Of course, they will stay around. It's not, that won't go away. So I think being really in, that area, dependent on your research area, I think starting with one of the three will give you a good start.
Oh, thanks. And is there any other question for Sandra?
I had one question, if I can please speak.
Please, go on.
Oh, hi, Sandra. Nice talk. It was very encouraging. And quick background, mechanical engineer, computational fluid dynamics experience. Presently a research associate at a university's high performance computing center. So I'm also associated with the USRC through the Slack and the conferences. One question is on the same lines as Francesco asked that, like you said, Fortran is not going away, but when you have when you talk to people in these conferences, I think people like to talk about the language in which more new developments happen. Not just language, but topics, right? So right now, many people talk about AI, many people talk about Python because data processing is easy in that. So, and also there are a host of different methodologies, right? Like for parallel computing, there is obviously OpenMP for portability, but CUDA for specific applications. So in such a world, when there are hyper-specific methodologies, I can't know everything, right? But right, so how, like, while in conversation, how do you project yourself as, like, it's difficult to project yourself as curious, but what I'm trying to ask is that how not to try yourself to sound very ambitious, but also sincere while talking to someone, either in an interview or just while like a light discussion in a conference that, well, I do not know this particular feature in CUDA, let's say, but I have followed some of the things in the past and shouldn't be too difficult. So how do you navigate such things?
So one thing I think there are these topics like AI, where I think nobody gets around that. If you want to be in research software, you don't have to become an expert, but you have to understand how to use it. And we have several projects now where we look into guidelines and how to start with, AI and what to do there. So we really try to help people and support them. Um, so the other thing is if you find out for yourself, let's say you're a mechanical engineer, so you have an area you are really interested in, and you like that one. So I would look into what are software packages there, what are people interested. Mechanical engineering, there are a lot of applications, for example, that need, therefore you called it out, OpenMP and OpenAPI. So getting into parallel concepts, so HPC centers have classes to get more into understanding. If you understand the concept for parallel programming, and maybe also go into the direction, okay, GPU seems to be for these problems I'm interested in, really the way to go. Look at the GPUs. I think nobody expects you to be an expert in everything, but understanding the level concepts and that you can say, I tried this. I understand why I need the high performance computing. That is what people want to know if you have an interview. Often, I mean, know, for example, Google is different. They have their, the exercises where you have to already program something almost perfectly and everything. But normally in research software engineering, at least the people I know, when we interview, we want people to understand the problems and that it is clear that you are ready also to get yourself into new concepts, because that is more important than knowing all the syntax.
Thank you.
Does that answer your question?
Yes, it does. Thank you so much.
Okay.
There is one more question, let's see, chat, and that is from, if I pronounce it right, as Adasa. And the question is, since AI code generation is getting more prominent, what skills would be good to emphasize or develop for future job interviews?
So yeah, so AI code generation will be in some areas really, let's say almost 100%, like creating the user interfaces or something, like HTML code, that we probably don't have to learn that in detail anymore. But what I think people should emphasize, that you are still learning programming, implementing like a craftsmanship, because without experience, you cannot find the errors in the AI code. And that is one day expected from you when you go from the junior level to the experience level, or to the mid level. You want to be the one who can say, oh, this code, that's what it's expected to do. And you cannot just learn it from not, letting AI create your code. You have to do still the hands-on, and I think that is something I would tell people. I'm still learning it myself. I compare it. I get help from AI. There's no harm done to say that. But understanding the concepts yourself, knowing how to program, knowing how to really also, there's a difference, and we all made the experience probably. You give AI something like, uh, uh, instruction, and the outcome is totally not what you expected. You're like, okay, I have to be more concrete. And I think emphasizing that you are very systematically learn what you have to tell AI, that you get good code while you are still also doing your own code, is something I think I would emphasize, because it shows that you understand that there are still many pitfalls with AI to just rely on it. And we never should really just rely on it.
Okay. Thank you, Sandra. So now I guess we can move forward to Gabriele. Okay. Thanks again, Sandra, for talking to us. Probably after there will be more questions. Now, Gabriele, you feel free to share and go.
Oh no, what am I doing? Let's see. Slideshow? Does this work? No, no spoilers. Do you see my screen?
Yes, absolutely.
Okay. Well, first of all, thank you so much for the invitation. It's very exciting to be here and tell you about this. As you'll see, I'll share a little bit of my journey, and I think our series are very important, and also they're very important for my personal journey. So I'm very excited to share this, my personal experience. And I decided to complement Sandra's talk by telling you what I actually do, or well, what I did as a RSE. So what is the day to day for a research software engineer? So for that, I would like to start with a little bit of my journey, how do I get here, and what's my background. So first, I need to tell you about numerical relativity. So I got my PhD in this field, and numerical relativity is just solving Einstein's equations on computers, typically lots of computers. And if you want to run simulations like the one that I have here on the right, binary black holes merging within an accretion disk, you need a lot of stuff. You need general relativity, you need to know about partial differential equations, numerical methods, differential geometry, fluid dynamics, nuclear physics, high performance computing, and a lot of software. So this is all to say that this field is not easy. There is so much that goes into, and it took the community many decades to be able to do this, to be able to run simulations like this. So in my particular case, I used this code, the Einstein toolkit, that took essentially, what, 20, almost 30 years, or it has been developed for over 30 years. And it's a giant code, has lots of lines, it's several languages, it was developed by lots of people. And this is a reflection of the fact that there is so much that goes into numerical relativity, and there were also so many unknowns. People didn't know how to do X, Y, Z. So this was truly a research code. And in this case, I use this code because it was open source. And this is very important for the field. Me, as a complete outsider, I could get to do numerical relativity and really stand on the shoulders of giants, because a lot of the work that had to be done was done by the community, so I could contribute and use this code. Um, Let me also know that there's lots of other codes, and none of them as big or sophisticated and rich in features. So the complexity is not necessarily all there. But then Einstein took it, and many big research codes are truly research codes. What I mean with this is the authors are researchers. They're grad students, they're postdocs, they're professors. These people use Einstein Toolkit or research codes to do research. And most of these contributors are not trained in software engineering. This means that the primary output that is seen in this type of work is the scientific research, it's not the code itself. Uh, and when this is the case, then there's tests, but there's not enough tests. There's never enough tests. There's documentation, but there's not enough documentation. Code quality is inconsistent, and in general, I personally found when I started using Einstein Toolkit, it was very difficult to use and extend. So there was a lot of time trying to, follow the code, understand, and going through, all this big bowl of like modules to understand what a particular switch does, or asking other people. Um, and to me, this is very common. Like, I'm sharing this as an example, but if in your own research, I'm sure you can, substitute this word Einstein Toolkit with your own code that you're using, and you'll probably have the same experience where there's not a lot of tests, there's not enough documentation, it's frustrating. And to me, this is a big opportunity, an opportunity to accelerate science. When things are difficult, we as a community produce less science that we should, because we're wasting time just getting things to work as opposed to doing our science. So when I realized this, I started doing something about it. I built this code, Quibbit, to essentially reduce the entry barrier, to take all of this complexity and shove it under the rug. Or not all of this, like at least a little bit of chunk of this complexity. So this meant being very careful of documentation, test, packaging, and all of this. And this is where I didn't know, but I was doing RAC work. So at the time, essentially, as a grad student, I was a research software engineer. And I didn't even know that this thing existed, research software engineer. So when it came time to graduate, and I was looking for what to do next, then that's where I really discovered the RAC can be a career trajectory. But before I get to that, I want to tell you how I was spending my day as a grad student doing this type of work in numerical relativity. And again, here is a laundry list of things, but probably you're going to share many of these things, no matter your life stage. Reading papers, writing papers, group meetings, going to conferences, run simulations, doing peer review, mentoring junior students, writing code, debugging code, optimizing performances. But then maybe I was focusing a little bit more on the software side. Maybe you're not going to do that, like developing software infrastructure. So things around packaging, testing, writing tutorials, writing documentation, things like this. And then, of course, all of this was to some extent in support of pushing my science forward. My science was simulations of binary systems and numerical relativity. But as I was doing this, I was trying to be helpful to the community and trying to really build something that other people can use. So this is what my day-to-day looked like as a grad student. And as was mentioned before, came time to graduate, was my quarter of life crisis. Oh my God, what do I do? And that's what I learned about RACs. I went on the RAC job board to find opportunities, and I think that's where I found my next job. And my next job was to some extent truly an RAC job. I moved to Caltech. I joined the Klima group, or Klima project, to build climate models. And here, I don't know much about climate science. I know about general relativity. So my role was more thinking about the software aspects of this. So I put this picture of lots of people because this is a big project. There's just a fraction of the people in this project. And what I want to emphasize is how my role changed from being a grad student to being a software engineer within a scientific project. And all these people matter because what changed is some of the things got de-emphasized and other things got more emphasized. Like the column on the left is what I did less at Klima, and the column on the right is what I did more. So what I really want to stress here is that I started working with other people a lot, partially to support them with software aspects, and partially to understand them, like work with them to see and try to co-develop our solution to a given problem. So essentially what happened is I gave away my science, but as you can see, not much has changed in many ways in my day-to-day. I still use my computational physics background. numerical methods. It was very useful to understand them. I moved from spectrum elements to finite volume, things like this. There is a lot that still came into play in my education that was very relevant at Klima. But then I was mostly focusing on these software aspects. So deploying good code, making sure that scientists, domain scientists, could do what they wanted and work with them to accomplish what we want. So less papers and more all of this. So this was in many ways a big RSC, like essentially a big RSC role. And after my journey at Klima, I took another step and I moved. Actually, no, I'll tell you that in a second. So what in my view, in my personal experience, what has changed is between grad school and Klima is I gave away my domain expertise. So what I'm trying to show you in this Venn diagram is that there is a lot of overlap between what I was doing as a grad student, working on my code, and what I then did as a RSC at Klima, with the big difference that instead of working in numerical activity, I had to work with someone else to push the science forward. So it's no longer my science, it was someone else's science. But the overlap in my particular case was quite substantial. A lot of work on testing, deployment, things like this. So to me, this is possibly one of, in your case as well, if you want to transition, and maybe looking at the question that was asked before on how to prepare or how to pivot, maybe you're already doing RSC work, and what you have to do is to some extent stop being the expert in something, being or in the domain, and being the expert in the software aspects of that. And this is something I found also in my next job, my current job. I'm currently an applied scientist at the Amazon Center for Quantum Computing. And I'm no longer quite RSC, but I'm still doing a lot of RSC like ish type of work. So we have codes. So these are the open source codes that we have. As you can see, we have computational electromagnetics. We have CAD codes. These are scientific codes. We use them for our internal users to make a quantum chip, but you can go and get up and see them. So there's a lot of work that is still RAC type of work. So to emphasize, to tell you once again, what do I do in my day to day? As you can see, the list is kind of the same. It's more or less what I was doing before, except that now I'm no longer just doing software type of work. I'm also pushing science forward, but not in the core domain. So the core domain in this case is quantum, and I don't work on quantum, but I work on numerical methods, for example, thinking about scaling, thinking about fast solutions, things like this. So in this role, I do more computational physics work. That's why it's a scientist role. It's not a software role, but it's a fluid role where I get to move between, well, let me work on cloud computing to, or now let me work on scaling for this type of algorithm. So the difference that I see is once again in where the science is my domain, is someone else's domain. In this case, is a domain that is not my core domain, is not the core domain of my organization, but it, to some extent is an adjacent domain to my training, is computational physics in the broader sense. So what I want to share with you today, I want to tell you, maybe you're already doing RSC work, so maybe just push more on that if that's something that you're interested in there. And second, as you can see, I got at least two interesting roles that are not in a traditional academic journey. I didn't do a postdoc, but I was using computational physics and RSC skills, and I'm still using computational physics and RSC skills in my day-to-day thinking about methods, but also numerical methods, but also infrastructure and things like this. So I also want to share that I have my own take on research software engineer, and I happen to have given a few talks, and one of them is recorded. So if you're interested in more about the history, and I don't remember if I talk about my own journey here, but I also share this link for if you want to hear more about me. And with this, I'm happy to take any question or yeah, anything that you might want to know.
Thank you very much, Gabriele. So is there any question? Oh, there is indeed a question. So I'll start with a question that is in the chat. Did you find there were any stumbling blocks switching from working with relativity to climate science? How much could you pick up on the fly?
Yeah, that's a great question. And so there is things that are similar, and then there's things that are different. And this is to some extent is where we can abstract away our skills as computational physicists. Things that are similar is we're still solving large simulations. It's no longer black holes, now it's Earth's climate. Many of the problems are the same. How do we scale? How do we get diagnostics? So there's a lot of things that it was very easy to switch because it's just I switched some, the vocabulary is a little different. Instead of saying Kreisoliger, I say artificial viscosity, things like this. A lot of my training was very easily ported to climate science. But then there was also a lot of that domain knowledge, like how I should expect the atmosphere to behave when there's a thermal inversion, things like this. The part of it I will pick up, but a lot of it was working with domain scientists. So I and that's what I want to emphasize to some extent. And as a grad student, I was the main scientist in the RSE, and so I could debug my own thing very efficiently because I knew exactly what was the physics behind it. But then in my next role, I really had to work with other people to push the science forward, but also to debug issues and get more physical intuition.
Is there any other question for Gabriele? And if not, I have a question. So like, if you had to start all over again, okay, what skill would you have wished to have already learned better from the beginning of your journey?
Yeah. So I I think I'm not very strong in machine learning. Um, and if you want to get a job, machine learning is very hot right now. So if you want to maximize your chances or your cross section of job applications out there, unfortunately, machine learning is very, very, very useful right now. Maybe machine learning is actually outdated. Maybe I should say AI. So I think I probably should have spent more time doing some, I don't know, machine learning project to at least be exposed to this.
Thanks. Yes, actually, I agree. It makes very much sense. um, is there any other question, both for Gabriele or Sandra?
I have one.
Please,
Can you
go
hear
on.
me okay?
Yes, absolutely.
All right. Gabrielle, so you were building on Theodore's question. You switched from working with relativity to climate science. I have been doing scientific computing or maybe even RSE, and I didn't know it, for computational chemistry for a while. But even whenever I look for job opportunities, I find that I need to have X years in this very niche area and Y years using some very niche software. Um, I'm wondering how I can promote myself when switching areas if my PhD work was in this one particular, like developing this one particular open source software when there's really no job opportunities for that one software.
Sandra, please go ahead.
Oh, I would have waited on your answer. I
Oh,
only
okay,
wanted
okay,
to, I
okay,
also wanted just to show that I'm happy
okay.
to answer that question. Yes.
Yeah, so also I'll try to give my take. I mean, that's a great question, of course. And I, I don't know the specifics of computational chemistry, but I know that there's roles out there that are, computational physics that are more general enough where your background will work. And the way you can spin your background is not necessarily talk about your specific software, but one, talk about how if you contributed to this open source software, how you change the software. Meaning, before people could not do this, but now, thanks to my contribution, we can do this, and this is very impactful. And then there's a lot of things that translate in terms of I use GPUs, I work with this technology. So um, this is not an answer because you're telling me that all the jobs that you find are for softwares that are not software that is not yours. But I'm pretty sure there's more out there that maybe you should just expand your view and not necessarily, feel like an imposter. That's not what I can do. You can probably do that if, so yeah.
Yeah,
Okay, thank you.
I would like to add, so for example, I came from industry and I did my PhD then in a bioinformatics group. So the biology side was totally new to me. Um, it is, you bring your already experience with some software with you. You you have the research scientific mindset, and I think in many groups really look at the USRC website. You are not expected to have all years of experience with different software packages there. Um, it's it's not well known yet in many institutions, but quite a few now. So Princeton, Notre Dame, San Diego, there are research software engineers teams. And if you are interested to really do this switch to another group, and it's always that, your scientific background is helpful because you have learned how to think about problems. Getting into other scientific problems, you don't have to be so deep into it anymore. You just have to understand an apostrophe just. And I think you can find positions that exactly fit for you, even though the, there will be always also job positions, oh, we want all this experience, but there are more positions out there really to support this, to switch between different areas and do the software engineering part. I encourage you to look at the job board of USRC.
I definitely will. It wasn't one that was on my radar until today. So thank you so much.
So there is another question from Michaela, and I think it's a question most of us can relate to. And it's like, hi, I'm interested in switching from academia to industry after my PhD, but I feel as I thought the software development skills I'm learning now are not rigorous enough. Would you recommend doing a postdoc in a group that develops a software package to gain more skills, or trying to jump straight into industry?
I mean, I don't know the specifics, but in my case, I didn't need to jump because I did a lot of work, essentially on my own. So I wouldn't necessarily, if you can get a job in the industry, that's your goal, I wouldn't necessarily say, do a postdoc, just try to get a job. A lot of it, unfortunately, is, lead code, is system design. That's something as a PhD you can definitely learn. There's nothing fundamentally wrong. You just have to put the time. Preparing takes a lot of time. So that's something that you feel strongly. Just start preparing. What I typically recommend people do is try to align their projects with more software projects. So I don't know, or try to maintain a package or build a package, things like that, as opposed to Jupyter notebooks, and work outside of your PhD, which is very daunting, but that's what you can do. Alternatively, if you don't feel to do, you want to do this now, it would make sense to buy yourself more time with a postdoc, but wouldn't necessarily say that you need to do a postdoc in a software package group, because what really matters at the end of the day is your hands-on skills that you can develop by yourself. You don't need to be in a group. That's my take.
Yeah, and I wanted to add that if you are interested really to learn more and how good practices, there are good classes at HPC centers, for example, if that is something you want to go in that direction, HPC, distributed computing, parallel computing. If you want to learn more AI, so there's also, and also here the hint, look at USRC at the education and training working group. Join there. So these are the discussions. What is needed? What do I contribute to an open source software package? You learn a lot by having then when other people have to use your code. So they have rules, and you can learn a lot by doing things like that.
Thank you very much. I think there is another question from Shangan. Should one develop extensive domain knowledge before applying for RSC jobs, or is the other way around?
Yeah, my take is it's the other way around. Your skills are very transferable. And most often you're not expected to be a domain expert. You're working with domain expert to be your own domain expert, where your domain is scientific software. So don't get a second PhD in climate science if you want to work at climate.
And I wanted to, the RSEs are very mixed. And honestly, the ones who come from computer science are even in the minority compared with people who are coming from domains, because often people found in their domains that they needed to do a lot of software and they had a lot of fun with it and they want to stay there. So I think you don't need extensive domain knowledge. Like, my take on interviews: be curious, be open to learn new things to a certain level that you understand the problems you want to create the software for. I think that is important. Not to be the domain expert if you want to become a research software engineer. You need to find the language to talk to domain experts. And sometimes the language is really, communication is a big thing, and you have to learn what they mean when they talk, for example, about workflow. That might be not a computational workflow, that they are, wording. But you don't have to become an expert in a domain. You have to be open to learn enough about the domains to be able to create valuable software for them.
Fantastic.
Hi.
Please go on.
Yeah. Hi. Yeah, you hear me, right?
Yes,
And
absolutely.
I should start sharing. Well, actually, I have a question for Gabriele. Yeah, if I pronounce your name correctly. So just now you mentioned you want to improve your machine learning technique. Well, my question is about, so in your current role, how you use machine learning techniques. I mean, is it highly related to science or related to software? I mean, based on my current understanding, if machine learning is incorporated with science, so this is one thing. Another thing is that it is incorporated with your software work, which is used to improve your efficiency. That's my understanding. So I kind of didn't get to why you want to improve your machine learning technique. Yeah, that's my question.
Yeah, the answer is both. We use machine learning for our scientific workflows, but also for our human workflows and the more software side. For example, we have a lot of data. How can we do this faster and maybe with less accuracy? So there's opportunities for both of us for both this type of workflows, and I'm going to explore both of them.
Okay, yeah, I see. So you mean you actually find that machine learning incorporate with science and it improves the development of science.
Yeah,
Right.
like the typical use case that I see is we can run very expensive simulations to get accurate results, or we can run like a machine learning model that is way less accurate, but it takes like 1/millionth of the time. And sometimes we can trade off that accuracy to be much faster.
Okay, I see. Okay, thank you. Thank you so much.
Okay, I guess we are time for just one last question. Then I guess it's time to stop. And all right, I guess then there are no more questions. So thank you again, Gabriele and Sandra. It was a pleasure to have you. Oh, no, wait. Sorry, there is one last question. For someone working at an RSC, how does the growth opportunity look like?
I think Sandra is best positioned to answer this.
Yes.
Thank you. Yes, so that is still a difference between institutions. I know that a lot of institutions start to have, you start like an RSE, then you become a senior RSE, and then there is an opportunity to grow into a little bit more management position, for example, like more a group leader, or more in a position where you are the expert for certain, let's say, for example, you are the expert in RSE projects for GPUs. So it goes expertise, or you go more into a management level. So that I've seen at institutions now, that they really do it in different levels, that there can be the growth. And if I know enough people also who said, oh, I don't want to manage people. People are annoying. I want to I want to become an expert or be the one getting asked and contribute maybe to proposals or something like that. So yeah, so there are different ways. Also here, I hope that we can contribute with USRC that more institutions pick that up and have more career paths where you can go certain levels and more levels.
You're muted.
Sorry, I say okay, thank you to everyone again for joining. And thank you to Gabriele and Sandra for being here. It was a pleasure, and I hope that this was interesting for everyone coming. Thank you. Thank you again.
Thank you. Thank you for having us.
Yeah, thank you.
Have a great day. Bye.
Bye.